Alright, ladies and gents, we are going on to Unit 7, Lesson 16. In this case, we're going to be working with two-digit divisors again. Remember, the divisor is the number that you're dividing with, so in this case, 22 for this first example. And they'll have two digits, so two numbers in them. One thing we want to show you is how to estimate when thinking about what number we want to try first. So when we think about this, if I have the number 22, and I'm taking 154 and dividing that number by 22, you use a little bit of estimation, because if you just do random numbers with your guessing and checking, you'll spend a lot of time doing guess and check. What I always like to do is I look at the front number here, which is a 2 here. In other words, I can think of that as the rounded number 20. Then I think about the first two numbers here, and I know that that's 15, okay? Then I think about 2 and 15. What's a number that would get me close to 15? Well, I know 2 times 7 would be 14. So if I now try 22 times 7, I could try and see if that gets me close to 154. Because obviously if I look at this as my whole divisor, 22 does not go into 1, so I put a 0 up. 22 does not go into 15. But remember, I used that front number 2 and thought about this front number 15. So let's try that. If I do 22 times 7 first, I'm going to show my work over here now. 7 times 2 is 14. Carry the 1 up. 7 times 2 is 14 again, plus 1, 15. Look at that. And that is a perfect match. So I know that 22 goes into 154 7 times perfectly, and I'll be left with no remainder. So using that front end estimation to think of numbers will help you solve these problems. Now, it doesn't always work in that case. Let's try it now with our second example. Here I have 68 68 going into 503. So I have 503 divided by 68. So again, I'm going to look at the front number and think, okay, 6 and look at 50. Okay, so if 6 goes into 50, I would think, what's going to get me the closest? Well, 6 times 8 would give me 48. So I'm going to try that first. And again, my whole divisor is 68. I know it can't go into 5. It cannot go into 50. So now I'm thinking, okay, how can I get close to 503? So I looked at my front numbers and decided I'm going to try with 8 first. So 68 times 8. 8 times 8 is 64. 8 times 6 is 48, plus 6 is 54. So I can see here that with 8, I went over. The reason for that is this is probably, when I use 6, I rounded obviously to 60. I probably should have used 7 or rounded that to 70. Because now I'm going to have to try a smaller number. Okay, so let's try 68 times 7. 7 times 8 is 56. And 7 times 6 is 7 times 6 is 42, plus 5 is 47. So now I have 476. So that's the closest I'm going to get now. So then I put my 7 up, and I know 68 times 7 is 476. Now I subtract. I'm going to have to borrow here all the way across. And now I have 13 minus 6 is 7, 9 minus 7 is 2, 4 minus 4 is 0. So I end up with the answer 7, remainder 27. So again, I use that estimation to help me figure out which numbers I want to try multiplying with first. Very handy skill.
All right, fifth graders, we're going to estimate using compatible numbers on this problem, and then we'll solve. I'm going to take 60 or 56, and I'm going to say that's about 60 because that's what it would round up to. And then I know 6 goes into 42. That's probably going to give me my closest number. So I put 4,200. And then I know with my 2 zeros that that's going to go in there about 70 times. So my estimation is going to be about 70. In fact, I'm going to try 56 times 7 and see how close it is to this 403. Might be too high, but we're going to give it a try. 42, 35, is 7 times 5 plus 4 is 39. That's perfect. Notice my 7 goes right over the 3, and I put 392 right lined up underneath the 403, and then I subtract. And this is where it's really important to check when you're done subtracting, that's smaller than your divisor, which it is, and then I bring down my next number. Okay, now again, a lot of times what I'm looking at is this front number into these front two numbers. I know 55 times 2 is 10, so I'm going to try 56 times 2. And look at that. Times 2, don't forget to put that number up there. It is 112. And when I subtract, I get 0. Now, my final answer is 72. Look how close my mental estimation is to that answer. It's a good way to help you start where to divide and check your answer at the same time. Know that your answer is reasonable.
All right, ladies and gents, we're going to go ahead and solve just the first step of some of these problems. And we have to think about, when we're using that estimation, what numbers are easier to make a mistake with. So when I look at number 5 here, I have 2,583 divided by 41. Okay, so first I'm going to look at this as 41 does not go into 2, so I'll put a 0 up. 41 does not go into 25, so another 0. 41 will go into 258, but now I have to think of what numbers to use. So again, I'm going to look at that front number, 4. So I'm imagining that this is essentially the rounded number of 40. Okay, so use that 4, and I have to think about, okay, 4 going into, say, I'm even just going to look at the first two numbers, 25 here. Okay, 4 times 6 would give me 24. So what if I tried 41 times 6 and see if that gets me to 258, or close? So let's try that. 41 times 6. Okay, 6 times 1 is 6, and 6 times 4 is 246. Excellent, that definitely worked, because I know I'll go over if I try times 7. So I'm going to put up a 6 and subtract 246. Okay, 8 minus 6 is 2. 5 minus 4 is 1. 2 minus 2 is 0. Okay, next I'm going to bring down the next number, which is a 3. Okay, so again, I'm going to think, again, that 4, that first number, and look at the first two numbers here, the first two digits. Okay, 4 and 12 are compatible. I know 4 goes into that 3 times. So what if I try 41 times 3 and see if that gets me close to 123? Okay, 3 times 1 is 3. 3 times 4 is 12. Oh, look at that. It worked out perfectly. So I put the 3 up. When I subtract 123, I'll end up with no remainder. I have no more numbers to bring down. So my final answer is 63. Excellent. Okay, so let's take a look at number 6. I have 1,525 divided by 34. Okay, so first I'm going to look at this. 34 will not go into 1, so I put the 0 up. 34 will not go into 15, so I put the 0 up. Okay, 34 will go into 152. I just have to figure out how many times. Now again, I'm going to look at the front number, 3. Okay, I'm going to look at the front two numbers here, 15. I know 3 goes into 15 perfectly 5 times, so I'm going to try 34 times 5 to see if that gets me close to 152. 5 times 4 is 20. 5 times 3 is 15, 16, 17. Okay, so 170. Oh, shucks. In this case, I did go over. Chances are, because I used 3, which essentially I had rounded to 30. Maybe if I had thought of that front number as a 4, that would have worked out better. But what I'm going to do now is try 34 times 4. Hopefully now I'll get close enough without going over. 4 times 4 is 16. 4 times 3 is 12 plus 1, 13. There we go. So this is the number I'm going to use now. So 34 times 4 gives me 136. So now I subtract. I do have to borrow from next door, so that becomes a 4. So 12 minus 6 is 6. 4 minus 3 is 1. 1 minus 1 is 0. Okay, bring down my next number, 5. And now I have to think, okay, 34 goes into 165. Again, I urge you to look at the front number. 3 going into 16. Here again, I would guess 5, but because I've kept my work, which I really, really urge you to do, I know that 5 won't work, because 34 times 5 is 170, and that's too high. So I keep my work from before using the 4, because I know that that's going to be as close as I get. So I'm going to put the 4 up, which I know is 136. So again, I show my work to subtract. So I had to borrow, so 15 minus 6 gives me 9. And 5 minus 3 is 2. I have no more numbers to bring down, so this becomes my remainder. So my final answer here was 44, remainder 29. So as you can see, boys and girls, this front end estimation that I'm using doesn't always work perfectly, but it does get you close. So I'm going to do one more example, and then I want you to solve number 8 on the back of your ticket, please. I really want to see that work. Okay? So let me solve number 7 now. Number 7 is 928 divided by 29. Now, here's where I see the number 29, and that would round up to 30 nicely. So this time, instead of using 2 as my front number, I'm going to use 3 as kind of my secret number here, because that 29 would round up to 30. Okay? So I'm going to imagine that there's a 3 out front instead. The reason for that is I need to think about a number that will work but won't go over. If I use 2, because this is 29, if I use 20 instead, chances are, if I use 29 and round that to 20, my numbers will go over. So I don't want to use that. Okay? So if I think about my secret number 3 here, which I rounded 29 to 30, so that's where I'm getting my 3, I know that I'll be able to use that to think of numbers to multiply by. So first, I need to look at my whole problem. 29 does not go into 9, so I put up a 0. 29 does go into 92. I just have to figure out how many times. So again, I'm going to use that 3 and think about first, okay, the front number. Does 3 go into 9? Yeah, perfectly, 3 times. So what if I tried 29 times 3? And the number now that I want to get close to is 92. So if I take 29 times 3, that gives me 27. 3 times 2 is 6, plus 2 is 8, and that's 87. Beautiful. So that's as close as I'm going to get without going over. So 29 times 3. Now I subtract 87. Okay, I've got to borrow here. So now I have 12 minus 7, which would give me 5, and 8 minus 8, which is 0. Bring down my 8. Okay, so now I have to think of how many times does 29 go into 58? Well, again, I'm going to use my secret number 3 and think about the number 58. Does 3 go into 58? If I think of my math facts, 3 times 9 is 27, so it's going to be a larger number. But now if I think about it this way, 30 going into 58. Well, I know 30 times 2 is 60, so that goes a little bit over. But I'm going to try it just to be safe, 29 times 2, to make sure that I can't get close, or maybe it even works out perfectly. It's always better to try it than to assume. So 2 times 9 is 18. Oh, I'm glad I tried it, because 2 times 2 is 4, plus 1 is 5. It goes in perfectly 2 times. So I'll write my 2 up. 29 times 2 is 58. Now I subtract, and there's no remainder. So my final answer for this one was 32. So again, boys and girls, the estimation isn't something that you have to do every time, but it's something that you can do to find numbers to multiply with much easier. Instead of guessing and checking all over the board, it makes the process faster for you. So I do want you to go ahead and try this for number 8, and please put this work on the back of your ticket.
All right, we're going to solve a word problem using our 2-digit long division method here. Hector picked 1,375 oranges in his fruit orchard. He will pack them into crates to take to market. Each crate holds 24 oranges, so I know I'm going to be dividing by 24. Okay, there's 2 questions. How many crates will he have? I'll get that when I divide. And then I'm guessing we're going to have a remainder, and that will be the answer to the second part, is how many oranges will be left over. Okay, again, I'm looking at 2 into, I'm going to round this to 1400, and I know that 2 goes into 14 7 times. So I'm going to try 24 times 7. No, I rounded too high. You can see already that's going to be 14. That's going to be 168, and that happens sometimes. I'm going to try 24 times 6. 24 carry 2 is 12. 14. Oh, look at that. That's still too high. So we're going to take 24 times 5. That happens sometimes. I leave my work here in case I need it on the second number. That's 20. 10 plus 2 is 12. Okay, so 5 is our number. Hopefully most times it doesn't take you 3 times. 2 is probably enough. When I subtract, I get 7, 17. Again, I check and make sure that's smaller in my divisor. It is. And then I bring down my number. Now, even though I messed up, my work here kind of pays off, because I don't really have to look and see what will go into 175. I know it's going to be 7 times because I already did the work, and that's 168. When I subtract here, I'm going to get 7. Okay, now I need to end. How many crates will he fill? And the answer is 57. And how many oranges will be left over? And the answer should be 7. Now I want to remind you, we talked about how to check your answer. So I'm going to take 57 times 24 is 8, 21, 0, 14, 10, 11, 8, 5, 3, 1. Okay, then what I'm going to do is I'm going to add my remainder. Okay, what did I do wrong here? I see a mistake. If I add the remainder 7, I would get 15, 6. I'm off by 1 in the tens place. I'll have to look and see what mistake I made. Okay, I found my mistake is right here. When I took 4 times 7, it's 28, and I only put a 1 up here. It should have been a 2. And then 4 times 5 is 20 plus 2 should have been 22 instead of 21. Right there was my mistake. And when I add, I got 8, 6, 3, 1. Now when I add 7 onto that, I would carry the 1 and would make it 1375. Again, it's good to check your answer, and it's easy to make a simple mistake like I did, carrying the wrong answer. But now look at 1375 is what I've got here, and 1375 was my divisor, not my divisor, my dividend when I started the problem. So I know that that answer is right. Remember, you multiply these two and then add the remainder to check your answer.
All right, ladies and gents, now we have a word problem to solve here to apply what we've learned. This says the skateboards at the Speed Demon shop sell for $76 each. This week, the shop owner sold $5,396 worth of skateboards. How many skateboards were sold? All right, so if I take the total amount, 5,396, and I divide that by the $76, I'll find how many skateboards were sold, because this is how much money he's earned in the week. This is how much he sold each skateboard for. So if I figure that out with division, I can find out how many skateboards were sold in all. So I take 5,396 divided by 76. Okay. So I know 76 does not go into 5. It goes in 0 times. 76 does not go into 53, so I put up a 0. 76 will go into 539, but here's where I need to think of how many times. So here's where I'm going to use some estimation. I'm going to imagine that this is 70, okay? So I'm using that front number 7, And I'm thinking about the front two numbers here, 53. What's a number that gets 7 close to 53? Well, let's think. 7 times 8 is 56, so that would go over. So if I do 7 times 7, that's 49. That gets us pretty close. So I'm going to take my divisor, 76, and multiply it by 7. Remember, we're seeing how close we can get to 539 without going overboard. So let's start showing our work. So 7 times 6 is 42. Carry my 4 up. 7 times 7 is 49, plus 4 is 53. Perfect. 532. That's as close as I'll get, so I'm going to put my 7 up here. 76 times 7 was 532. Now I subtract. 9 minus 2 is 7. 3 minus 3 is 0. 5 minus 5, 0. Beautiful. Bring down my 6. Oh, hey, look at that. Does 76 go into 76? Yes, it does. Perfectly one time. So now when I subtract 76, I'll end up with 0 remainders. So that tells us, to answer the question how many skateboards were sold, I'll answer that with 71 and label it skateboards. 70 skateboards were sold. So again, boys and girls, you'll notice that I used that estimation to help me figure out what number to multiply with. And again, it worked really well. I didn't have to do guess and check forever and ever and ever. I found a number, it got me close to where I needed to be, and you could see that I was able to solve it much faster than if I had just randomly guessed. So that estimation really is a handy tool.
All right, fifth graders, you do have a ticket to class, and I do want you to do number 12, story problem on the back of your ticket. And again, use that compatible numbers to try to pick what your answer is, estimate to make sure your answer is reasonable, and bring this back to class, and good luck.